This is Mrs. Benke, and I'm going to be explaining your activity today. We're moving on to a new chapter on balancing chemical equations, and in your activity today you will be simulating that with building blocks. So what you need to do is get a sample bag from the middle of the room and then take the card out of the bag. This particular card gives you a skeleton equation, which is your basic framework of your equation. It's just not balanced. In this case, our skeleton equation is P2 plus Y2 yields P2Y. Notice that the arrow sign is called a yield sign, and it's basically like an equal sign would be in a math problem. The letters here are going to represent the colors that we're dealing with. So P represents the purple blocks and Y represents the yellow blocks. Anything to the left of the arrow is called a reactant. That's what goes into the chemical equation. And anything to the right of the arrow is called a product, which is what you get out of the chemical equation. So what I want you to do is put your card down in the middle of your lab table, and then I want you to start building the molecules that are described on your paper. This says P2, so that tells me that I need to take 2 purple blocks out of my bag, and I need to stick them together. So a P2 looks like this, 2 purple blocks. I'm going to set that down on the left side of my paper. Next I have Y2, which tells me I need to take 2 yellow blocks and I need to join them together also. So this is a Y2 because there are 2 yellow blocks that are connected to each other, and those are my reactants. On the product side over here on the right, I want to build a P2Y. That tells me I need 2 purples plus a yellow, which I have right here. Because the letters are all connected to each other, this means that I need to connect my blocks to each other as well. So I'm going to connect my 2 purples and my Y, and that gives me a P2Y. Now what I want to do is start comparing how many blocks of each color I have on either side of my equation. So I'm going to start on the left side, and I have 2 purple blocks. On the right side, I also have 2 purple blocks, which means my purples are balanced. On the left, I have 2 yellow blocks, and on the right, I have 1 yellow block. So I know I need to add more yellow over here on the right, and I can't just take a random yellow block from my bag and throw it in and say, okay, now my equation is balanced. It doesn't work that way. The only way I can add more yellow over here is if I build another molecule that looks exactly like what I already have on the product side of my equation. So that means I need to get 2 purples and stick them together. And I need to take this extra yellow that I need and also stick that onto my molecule. So now I have 2 P2Ys over here, and that's great because it gives me the 2 yellows that I need to balance with the 2 yellows here. My problem is that by adding another one of these, I've increased my number of purple blocks. So now I have 4 purple blocks on the right and only 2 purple blocks on the left. This means I need to go back to the left side of my equation and I need to add more purple blocks. And again, to add more purple, I have to build what's already there. So I'm going to need to take 2 purple blocks and join them together to add another P2. Now I want to go back and double check. I have 4 purple blocks on the left and 4 purple blocks on the right. I have 2 yellow blocks on the left and 2 yellow blocks on the right. So that means that my equation is now balanced. You're going to want to take a piece of notebook paper and write your station number down on it, and then you're going to need to write the balanced chemical equation. To write a balanced chemical equation, start with the skeleton equation that's given to you on your paper. So P2 plus Y2 yields P2Y. Then I need to go back and add what's called a coefficient, and that's just telling me how many of each molecule I have. Here I have 2 P2 units, so I have to add a 2 in front of my P2. I only have 1 Y2, and we don't write ones, just like when we were writing chemical formulas, we don't use ones. So I'm just going to leave that as a Y2. Over here on the right,